Firstly, we draw a straight horizontal line and draw a vertical line LL' somewhere close to the midpoint of the horizontal line and mark the point of intersection as O. O in this case is the optical center, LL' is the lens. In the second step, we mark the points F and 2F on both the sides of the lens LL' such that OF equals to 2 cm. This 2 cm is taken so that the ray diagram fits in your copy. We also take the distance of 2F from O as 4 cm so that the distance of 2F from F is also 2 cm. These distances have to be measured accurately. In the third step, we place the given object of finite size exactly at the given point and name the object. As per the sign convention, we always keep the object on the left side of the lens, that is, in front of the lens. Now, in order to locate the exact position of the image formed by the lens, we require at least two convenient incident rays from the object. The first ray is incident parallel to the principal axis, and the second ray passes through the optical center. Now the ray, which is parallel to the principal axis, after refraction passes to the second focus if the lens uses convex lens, and the other ray passing through the optical center passes undeviated. In case of a concave lens, the ray parallel to the principal axis after refraction diverges as if it diverges from its second focus F, and the second ray passing to the optical center passes undeviated. In case of a convex lens, the point at which the two refracted rays actually meet is the image of point A. We mark this point as A'. The perpendicular drawn from A' on the principal axis is the image of the object AB. In case of a concave lens, the refracted rays are diverging. If these two refracted rays are produced backward, they appear to meet at the point A'. The perpendicular drawn from A' on the principal axis is the image of AB.
Dear friends, as you are all familiar with the 6 steps for constructing the ray diagram, here I have taken one example where the object is kept at 2F. As you know, the first step is drawing the horizontal line, straight line, and somewhere in the middle of this horizontal line we draw this vertical line in such a way that OL and OL' they are equal to 3 cm and 3 cm. This O is taken as the optical center of the lens, and this LL' is the lens. If it is a convex lens, you can complete it. If it is a concave lens also, you can complete it like this. Now the second step is to locate the positions of F to F on either side. The distance of OF, for convenience, we take it as 2 cm, and the distance of 2F from F also, we take it as 2 cm. This side also 2 cm and 2 cm. This is taken as 2 cm so that the diagram fits in your copy. So now the third step is placing the object at the given point, and the object is placed at 2F in this case. So we are placing the object here. So in order to place the object exactly at 2F, so we keep the object here. Object is kept exactly at 2F in front of the lens. In front of the lens means the left side is taken as the front of the lens and right side is behind the lens. So this is the object, and the object can be marked as AB. When you take the height of the object AB, you should keep in mind that this height should be less than this OL. Now the third step is, from the tip of the object, we take two incident rays. One ray is taken parallel to the principal axis, exactly parallel to the principal axis. This is one convenient ray. And this ray of light, after refraction from the convex lens, it passes through the focus, second focus of the convex lens. This ray gets refracted like this. As convex lens is converging lens, this ray of light is converged like this. Another ray of light we take from the same point, and this ray of light is taken like this. It passes to the optical center, and you know, when a ray of light passes to the optical center, the light passes undeviated, goes straight like this. These two refracted ray, I can call this as ray number 1 and this as ray number 2. These two refracted rays, after refraction from the lens, they are actually meeting at this point. So let's say this light is coming from A, therefore I'll mark this point as A dash. Now from A dash, I'll drop perpendicular on the principal axis, and this becomes point B dash. So you can clearly see that A dash B dash is the image of AB formed by this convex lens. Now let's write the characteristics of the image formed. So it will have two steps. First one is the nature of the image formed, and the second one is the position of the image. In the first case, we have the image formed is real, because we have already seen that the rays of light after refraction were actually meeting and forming the image. So such kind of image is real image. And the image was upside down, so the image formed is inverted. And the image formed is of the same size of the object. The image and the size of the object that we measured were equal to each other. The position of the image is formed at 2f but behind the lens. So these are the characteristics of the image formed by a convex lens when the object is placed at 2f. In this case also, we'll be placing the object at 2f, but instead of convex lens, here we have taken a concave lens. First step is drawing this horizontal line and drawing this vertical line somewhere in the middle. And after that you mark the points F to F, and this distances, whatever you measure, this distances have to be exactly correct. So we place the object at 2F. The height of the object I am taking as 2 centimeter, exactly 2 centimeter. This is the object. Object is AB. Now, once you place the object in front of the lens, its image will be formed. Now, where this image will be formed and what will be the characteristics of this image? In order to know that, we draw the ray diagram. One ray is taken parallel to the principal axis, like in the previous case. In all the diagrams, we follow the same thing. We draw this line, first convenient ray parallel to the principal axis. This ray, after refraction from the concave lens, as concave lens is diverging lens, it diverges like this, as if it diverges from the second focus of the concave lens. It diverges like this. Another ray of light we take from the same point A, and this ray of light passes to the optical center. And you know, when any ray of light passes to the optical center, it passes without any deviation, goes out straight like this. These are the two refracted rays. These refracted rays are diverging, which means if they are produced in the forward direction, they will not meet. So that is why what we do, we produce them in the backward direction like this. When they are produced in the backward direction, they appear to meet here. So the image is formed here. This is A dash, B dash, which is the image of AB. Now it is clear to you that this image is formed not by the actual meeting of the rays, but by the rays of light which appear to meet when they are produced backward. So that is why this image is virtual image. This is upright also, erect also. And you can see the size of the image and the object. Object is 2 centimeter, and if you measure the size of the image, it is less than 2 centimeter. So you can say that the image is diminished. And it is formed in front of the lens, not behind the lens, in front of the lens. Let's see its characteristics now. The image formed is virtual, the image formed is upright or erect, and the image formed is diminished. And if you see the position, the image is formed in front of the lens. So for concave lens, I'll be showing only one diagram, because wherever you keep the object in case of a concave lens, the image formed will have the same characteristics. In another example, we have taken a lens, convex lens, and here we are keeping the object at the focus. So you know, you draw this horizontal line, vertical line, mark these points F and 2F, and measure the value of OF, the distance of 2F from F, exactly as 2 centimeter. Why 2 centimeter? I have already told you, because if you take more than this, then the diagram may not fit in your copy. So that's why we are taking 2 centimeter. So as required, we keep the object exactly at the focus. I am taking the height of the object as 2 centimeter, exactly at the focus. This side is, left side is the front side, so right side is the back side. So we are keeping the object in front of the lens. One ray is taken from this object AB. One ray of light is taken parallel to the principal axis, exactly parallel to the principal axis. As it is a convex lens, this ray of light after refraction passes to the focus, second focus of the convex lens. Another ray of light you take from the same point A, and from here you take another convenient ray, and this ray of light, as it is passing to the optical center, it passes without any deviation, so goes out straight like this. Now if you look at these refracted rays of light, they are parallel, meaning that if they are produced forward also, backward also, they are not going to meet. But in practice, what happens when the object is kept at the focus of the lens, convex lens, image is formed, and that image is real image. So that is why what we do, we imagine these refracted rays after refraction from the lens, they will meet each other at infinity. So that is why the characteristics of the image in this case will be like this. The image formed is real because these rays of light after refraction, they will meet at infinity. The image formed is inverted because if the image is real, it will be inverted also. And the image formed is highly magnified or enlarged because the image is going to meet at infinity. And the image is formed at infinity. That is the position of the image formed. In this last example, we'll be keeping the object in between the optical center O and the focus F. So I'll be keeping the object in between O and F, not this side, because this side is behind the lens. I have to keep the object in front of the lens. So I'll be keeping the object somewhere here in between O and F. Let's say this is the object. This object is AB. From this object, from the tip of the object, we take one ray of light parallel to the principal axis. As it is a convex lens, this incident ray after refraction will pass to the second focus of the convex lens. It goes like this. Another ray of light we take from the same point A, and this ray of light passes to the optical center. And you know, when the ray of light passes to the optical center, it passes without any deviation. Goes straight like this. You can clearly see in the diagram these two rays of light, refracted rays of light, they are diverging, meaning that if they are produced in the forward direction, they will not meet. So what we do, we produce them in the backward direction. This ray also will be produced in the backward direction. These refracted rays, when produced backward, they appear to meet here. Therefore, the image will be formed here. So this is the image. So I'll mark the image as A dash, B dash. So in this case, the image is formed not by the actual meeting of the refracted rays, but it is formed by the rays of light which are produced backward. These refracted rays of light, when produced backward, they appear to meet here. So that is why this image formed is virtual. And if you measure the size of the object and the image, you can clearly see in the diagram the image is highly magnified. So convex lens in most cases forms the real inverted image, but it forms the virtual magnified image when the object is kept between optical center and the focus. So if we write the characteristics of the image, in this case the image formed is not real but virtual. The image formed is, since it is virtual, it is upright, or you can say erect. And in the third case, the image formed is magnified or enlarged. So if you mention the position of the image will be images formed in front of the lens, not behind the lens, in front of the lens. Similarly, you can keep the object at other different points and try drawing the ray diagrams to locate the position of the image formed, and you will write the characteristics of the image also. Thank you.